It says the ball is launched. Yes, it goes over 2D motion. It says it's launched with a velocity of 2 meters a second. The time, or with a horizontal, I should say, velocity. So which direction is horizontal? Straight out, right? Left and right. X direction. The time between each point is 1 second. All right. So if I look at my chart, the chart I'm going to give you is not going to have the velocity vectors. You're going to have to draw those. It's going to be one of the things it's going to ask you to do. But each one of these points is 1 second. So how many total seconds is my path here? If I start here at 0 seconds, how many total seconds is this ball in the air? 1, 2, 3, 4, 5. I'm in the air for 6 seconds. All right. Now, like I said, I'm going to say to draw the x and y velocity vectors on this chart. You're just going to have the points. Now notice my x direction vector, velocity vectors. Will that ever change, my horizontal velocity? No, once something's launched, that velocity stays the same. So all you would do is draw this arrow pointing straight out. We've done this before, but it's been a while. Now, how fast is that going? Well, it's given to us in the question, right? How fast is our horizontal velocity? 2 meters per second. Good. So I could draw this, and I could label it all 2 meters a second in the x direction. That's no problem. It's going to want to know my velocity in the y direction each time. Well, how long does it take to get to this highest point? 3 seconds. This is 0, right? 1, 2, 3. It takes 3 seconds to get up there. What's pulling it down the entire time? Gravity. Now, in this case, we got to go back to projectiles. Gravity is going to be negative. 9.81 meters a second squared.
Can you record this while I go to the bathroom?
What I'm going to ask you to do here is fill in a chart. The chart is going to say points. Yeah? Sure. Velocity in the x, velocity in the y, and the acceleration.
Sorry.
Looks something like that, right? Before I do anything, let's fill in what we know is never going to change. 2 things about this projectile will never, ever change. Who remembers what those 2 things are?
Where you threw it
Where I threw it from, but I'm talking about once it's launched in the air. Velocity in the x, right? My horizontal velocity never changes. It will always be 2 meters a second. So this is 2 meters a second. So right now, I just filled in 7 data points. Who can tell me how many data points are actually on here? You get 7 times 3, 21. I just filled in 1/3 of my question's answers. Just remember that my velocity in the x never changes. I'm 1/3 of the way to 100%. Okay. I can fill in 2/3 of this if I remember there's one more thing that will never change about a projectile. What pulls it down?
Gravity.
So my acceleration is? And it stays the same all the way down, doesn't it?
Yeah.
I now have 14 out of 21 data points. I am 66% of my test, and I've done nothing on this question but fill in something we've known all year long. I know one more data point, actually, that is given to me just by looking at this, without doing any math. How fast is my velocity in the y direction at my highest point here? 0. So this is point, if this is A, we got A, B, C, D. At point D, halfway through, I know I have 15 out of 21. That's like a 68%. We haven't done anything. I just wrote down what was given to us. The only thing we have to figure out is how fast we were traveling at the initial point, after second 1, after second 2, after second 4, 5, and 6. Now let's take a look at this, and let's get some review done. However fast I throw this at has to be equal and opposite to how fast it hits the ground at, doesn't it? Yeah. So when I'm talking about velocity in the y direction, it's going to hit the ground with the exact same speed, but in the negative direction that I throw it up with. Well, after 1 second, however fast it's traveling in the y direction after 1 second has to be equal and opposite to this point over here, right? So after 1 second, that would be equal to point F, or 5 seconds. After 2 seconds, whatever value here has to be equal and opposite to 4 seconds, this point here. Does that make sense? So I only have to figure out second 1, 2, and 3. That's it. That's all I have to figure out. Well, this deals with this equation right here. Now, I don't ask you to list the time, but what I would do on this question is I would list that this is 1 second, or 0 seconds, I'm sorry. This is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. By doing this, I can figure out my velocity at any point. There are 2 ways. I can do this mathematically. Okay? And I can calculate. I can say, well, after 3 seconds of time, my velocity final in the y direction would be 0. My acceleration is always going to be negative 9.81. I can figure out my initial velocity starting over here. Does that make sense?
Yeah.
So I could start off with my initial velocity by doing that. And it would look like this, for those of you that need to see it. That would be 29.43. Negative 29.43 is equal to a negative VI. So what happens to my negatives? Turn positive. Which means we also know how fast we hit the ground at, right? It has to be equal and opposite.
Equal and opposite.
We just got a passing grade. Just got a passing grade on this question.
Congratulations.
All we have to do at this point is change our time. Well, here it's 2 seconds, right?
Yeah.
We know our acceleration. We now know our initial velocity. So if I wanted to do this equation for 2 seconds, I would say negative 9.81 is equal to my final velocity minus my initial, which is 29.43 over 2 seconds. That'll tell me my final velocity at B. That's going to end up being 19.62
Someone's ever come out of my mouth.
meters per second.
And then the other one.
This would be negative 19.62.
Do it. It was supposed to come out really quiet, but it was like.
Now, I promised you a way to do this with math and without math. And I'm going to show you this last one without math.
It was like all up in my lips.
At what rate am I changing per second? I'm changing my gravity every second, right? Which means I can start at my pinnacle and count down my gravity each second. So right before here at 3 seconds, I should have 9.81 meters per second I'm traveling. And here would be a negative 9.81 per second. Gravity times 2 is 19.62. Gravity times 3 is 29.43. Gravity determines how fast you are in the air, or traveling in the air when you're in free fall. And it doesn't matter whether I'm going up or down. So if I could just remember how to count by 9.81, or just multiply 9.81 on your calculator, or the ultimate cheating method, velocity is equal to acceleration times time. Acceleration in this case is gravity.
Yes, it is.
So what would my velocity be at 1 second? Well, gravity time, or my velocity be at 3 seconds?
What is going on? You want to tap that?
So this would be a velocity function. It would solve it out for us, which is essentially the same thing we did right here. And you do get this formula. But the ultimate cheating method is just to count backwards by gravity. I know at here my velocity in the y direction is 0. I'm no longer going up. I'm not going down yet. My velocity in the y has to be 0. So right here, my velocity in y, if this is 1 second difference from here to here, my velocity in y has to be gravity, 9.81. But it's going up, so it's going to be positive. If this is 2 seconds, my velocity has to be double gravity. And this is 3 seconds, my velocity has to be triple gravity. And my numbers over here are just going to be the negative of the numbers there. So if this was gravity, this is negative 9.81. If that was positive 29, this is negative 29. If that was, or 19, this is negative 19. If that's positive 29, this is negative 29. It's that simple. Your question? Velocity initial? What is it? Like right here, what the number, or do you want me to define it? The number, 29.43 meters a second. Because remember we found out your final velocity after 3 seconds was going to be 0, right? Gravity is negative 9.81, so you can solve for initial velocity. Or you could just go here and you can count backwards by gravity. Either way works for me. What you're going to be graded on is filling in this chart. 15 out of the 21 data points you can do without doing any math. They're given to you. This number should never change. This number should never change. In the middle of your trip, you should be at 0. These 3, or these 6, or really 3 is what you have to solve for. Should be fairly easy to count to by this at this point. Everybody got that? That will be one of your questions. I will change one of the numbers. What's that? Use the acceleration formula. They're both the acceleration formula. The easy way, though, is just to count down by gravity. 0, 9.81, 19.62, 29.43. Just times gravity by however many seconds. And here it's got to be negative since we're going down. It's going to be negative 9.4, negative 19.6, negative 29. All right. You're going to do a lab today. 4 questions to go over. Your performance final is 3 questions. We went over one of them on Monday. The other 2 I'm going to go over today. One of them is a force diagram question. The other one is a interpreting graph question. So, you may take notes. You may write this down. You may take pictures. Anything you want to do, but I will not post it on eClass for you to get later. The only thing I'm going to do is change the numbers when it comes to the performance final. Everybody understand? Okay. So let's take a look at our performance final questions. Yes. Sure. This is the first question I will ask you. Looks just like this. A force is applied to a box with a weight of 130 newtons. It is moved across a rough surface with a constant velocity. The object encounters 32 newtons of force of friction. Complete the chart here. This is the first question I ask you. All I'm going to do is change these two numbers. But if we can solve it, we can solve it for any number. So let's take a look here. We want to complete this chart.
Casey. Okay. No, it's at an angle. Okay. No, I got it. He's so tall.
All right. So when I see a problem like this, the first thing I like to do is actually draw a picture. It makes things a little easier. This is a box diagram picture, or force diagram question. So, if I have an object moving across the surface, it says the weight of my object is 130 newtons. So that's the weight of gravity, force of gravity pushing it down, right? So, we represented this with an arrow like this, right? This would be 130 newtons, equal and opposite, right? Okay, I like to do that. It says, all right, so I like to draw a picture to help me out. Now let's start filling some stuff in. Well, the weight. Well, that's the force that pushes me down, right? That's 130 newtons, isn't it? It's given to me in the problem. It even tells me. Applied force. Well, we just drew the picture, so that makes it really easy, doesn't it? What's the force of friction? Negative 32. I'll accept 32 or negative 32. I'll accept absolutes. Technically, the weight would have to be negative, I guess. All right, first math question. Net force. Who remembers the equation for net force? Look like this. What's that big goofy looking thing mean in math?
It means I love you. Can I have this book?
Anybody remember?
Can I have that book? Can I use it?
Nobody?
Yeah.
Never seen that before? It means sum.
Something.
Sum. So what is a sum in math?
The total of adding them together.
Yeah, total of adding them together. Adding them all together. So the sum of all my forces is my net force. Well, what's this plus this?
Like,
What's
don't
this, what's
say
this?
if you can't handle it. Like,
If I have no acceleration, my net force has to be zero. That's Newton's first law again. An object in motion remains in motion in a straight line at a constant velocity unless acted on by unbalanced force. So if my forces are all balanced, my net force has to be zero. So do I have an acceleration? No. Yeah. That one's really easy.
So what, I got a question.
Yes.
What if that negative 130 was positive? Where would it go?
It would be facing the other way.
It would-
Positives to the right, negatives to the left.
Oh,
So that's all that means. Positives up, negatives down, just like in math. So since friction opposes motion, it's pointing this way. So motion is going negative. Friction should always be negative. All right, coefficient of friction. This is really the only math question I give you. And if we remember, this formula is on our formula sheet. And that means the force of friction is equal to the coefficient of friction times the normal force. But I gave it to you like this, and I like it in this form a little bit better. So we did this in lab using our textbook, pulling it across the floor. And that said the coefficient of friction was simply equal to the force of friction divided by the net force, or the normal force. Well, what's my normal force? 130, right? What's my force of friction?
I'm sorry.
Negative
It
32.
took me a while to accept.
In this case, we'll keep it positive because this is just a ratio. That's 32 over 130. If I do my math, I get about 25%. That's question A. Question B says to draw a vector diagram. Well, what did I start this problem off by doing?
Wait, so this is what the third drawing?
This is the first question I asked you.
I know, I'm saying this now, you said there's 3 questions.
Yeah. This is the first question I asked you. I asked you the third question. We did the third question on Monday.
You just said it's the section B, so. No, it's just 2 parts of it.
2 parts. There's 2 questions. First one was fill in this. Question B says draw a vector diagram. Well, I started my problem off by drawing a vector diagram. So that's already done. So that is the first question I asked you on the performance final on Monday. Easy, right? The last question I'm going to ask, well, the second question, but the last question we'll go over, so the third question, is nothing more than an interpreting a graph question. Everybody good on the force of friction? All right. I can't make it any easier than this. I'm going to change the numbers, that's it. Now, the graph question.
Oh wait, never mind.
This is our graph. It is a velocity versus time graph. We haven't seen one of these since August, but we have seen these before. So this is velocity on the y-axis, this is time. Anybody remember what the slope of a velocity versus time graph is?
Wait. What's the question? I didn't get it.
The slope of this line is a velocity versus time. You remember what that equals? What's it equal to? Rise over run, yeah. So it's a change in velocity over a change in time. What formula is that?
Acceleration.
It is the slope, but what's that?
Even acceleration.
Acceleration formula. I was waiting for somebody to say it with confidence.
Acceleration.
Thank you. The slope of a line in a velocity versus time graph is acceleration. The other thing I want to review with you is the area under the line is the distance you travel. Now, there's several ways to answer all the questions. I asked you 3 questions about this graph, and there's several ways to answer these questions. We're going to go over a couple of them. And it'll come back, hopefully it'll come back to you. But the graph question is my favorite because all the information you need is right here. Whether you'd like physics or not, or no physics or not, everything you really need is on this graph. So if we can just remember some of our basic algebra, this will be just fine. Now, I will change the graph. Will look generally like this, but I change where it starts and stops on the test. Does that make sense? So these numbers that we're going to get won't be the exact number. You can't copy these numbers down on the test or get it 100% wrong. You're going to have to redo what we do here on the test. Does that make sense? Okay. Just so we're all on the same page. First question I ask you is determine the magnitude of the acceleration from point A to B. All right. We have. This is point A, this is point B. Now we said acceleration was the slope, right? And slope is the rise over the run. So this is my first point. What's my coordinates for that point? 0, 0. Over here, what's my coordinates here? Does anybody see that? This is a 4,
5.
5. So it's going to be 4, 5, x, y, right? Let me write it up here. This is. All right. So to find the slope of that, I use my slope formula, right? Right? So my slope, which is my acceleration, is going to be 5 minus 0 over 4 minus 0, which is going to be 1.25 meters per second squared. That's A. Now, I'm going to erase this, so make sure you got it. So, what is the distance traveled from point B to C? So if I look here, there are 3 ways I've taught you how to answer this question. This is B, this is C, right? Now I could break out my distance formula. One that looks like this. And I can figure out my acceleration from here to here. I can figure out my time from there to there, and I can figure out my velocity from there to there, right? My initial velocity from there to there. And I can use this formula, and it would work out, it would give me 20.
It's just not something to joke about.
I could also remember that a flat line, what's my slope here? 0. So that means that my distance there is really just going to be my velocity times time, and that would still give me 20. But the way I want to show you, it comes in handy, is the distance on a velocity versus time graph is equal to the area under that line. What kind of shape is that? It's a rectangle, right? Well, what's this side right here equal to? 4. 1, 2, 3, 4, right? What's this side right here equal to? 5. Right? How do I find the area of a triangle or rectangle? Times width. My distance here is going to be 4 times 5.
What the fuck is wrong with you?
20 meters. We did this way back in August. I ask you a third question. I ask you for the distance you travel from point C to point D. This is the hardest question I ask you in the entire test. I want to know this distance. It's still equal to the area under the curve, right? But now I have 2 different shapes. I have this original triangle or rectangle, right? What's the area under here? 20, so we know that's 20. Right? But now I have this one up here.
Pythagorean theorem, right?
Don't even need Pythagorean theorem. What shape is that? It's a triangle. What's the area of a triangle?
Oh, my bad.
Well, what's my base right here? Still 4, isn't it? 1, 2, 3, 4. All right. What's my height? 2. So my area here would be 1/2 times 4 times 2, which would be 4. So my distance I travel here would be that plus this. So between points B and or C and D, I travel 24 meters. We have just done the entire performance final together.
Wow! No.
He just went over it.
Yeah, no.
Makes more sense to take it now.
Everybody has to take it on Monday.
You were recording him.
You will take it on Monday.
gotta study tonight.
But as you can see, every question I've given you before, right? We've done everything in here before. It's just been a while since we've done these. And not only